All right, welcome to the afternoon. It's 1:15, and I like starting on time. It's because of the German in me, I think. This is the most people and the most educated people I think I've ever presented to. So I appreciate the honor to talk to you today. And I feel apologetic for the pretentiousness of my title. You know, when I was looking at it just before I started, I was like, oof, wow, should tone that down. But it's too late, right? It's already in the thing. I also try to think about what I should tell you about myself so that you know that I'm potentially worth listening to. I'm used to being able to say I have a PhD in inorganic chemistry and moving on, right? That's enough. So I don't think, for example, the fact that if the room and I had a nerd competition, the fact that I would win, I don't think that that's going to help much. Like, does anyone here have a favorite platonic solid? How about know what a platonic solid is? There's a few, right? My favorite is an icosahedron. I can't explain that, right? But it is my favorite. It's a beautiful thing. So instead of more academic credentials, I'll tell you a few things. Like, for example, I was homeschooled until I went to college. I went to Hillsdale. I discovered that there's a cabal of Hillsdale graduates here. And I actually attended, I think it's CCLE number 2. I attended when I was like 14 or 15 in homeschool high school. I still actually remember Dr. Veith reading In Memoriam by Tennyson to the lecture room. So other than that, I'm married. I have 2 sons. My wife is from Greece. So I'm on the 50-year plan of learning how to speak modern Greek. I'm 10 years into the 50-year plan. I can basically, I'm sort of like a 3-year-old. So there's that. Some formal education things about me. Before I went to college, I went to the International Academy of Apologetics, run by Dr. Montgomery, and then I went to Hillsdale. After Hillsdale, like right away, I went to Purdue and I became an inorganic chemist. And then after that, I went basically, Concordia, Wisconsin hired me, and that's how I went to my advisor and said, I'm done now. You have to let me graduate. It worked. I got a job, then I got graduated, and so I've been teaching there for a while now. While I was there, I also went through the teacher colloquy process, which is fun because I worked out to be able to take Old Testament and New Testament on campus in class with a couple of the professors there, and that was really a good thing for me. At Concordia, I teach a whole bunch of classes. I teach all these chemistry classes, introductory chemistry, descriptive inorganic chemistry. I mean, they hired me to teach chemistry. I'm the only LCMS chemist. So I have taken it as one of my callings there to try to introduce faith and science disciplines and really try to help the science students with their faith and the challenges that they may struggle with. Recently, Concordia had the core class, which is the science and humanity class. And what I'm going to talk about today is actually a project that I do with a class that I think is really fun and has a lot of connections and things that you can talk about as an illustration or a metaphor for the relationship between the Christian faith and science. And so about halfway through, I'm going to beg and plead you all to stand up and play with the puzzles that I have around the room. Meantime, you can ignore that they're there, and then we'll see how that goes. I'm used to talking about things like this. This is a slide. This is what I'm used to talking about, so I'm sort of getting used to talking about something else. I did want to briefly make a case that I believe chemistry is actually a liberal art. Right? It grows out of natural philosophy. I really believe that The search for truth and beauty and finding truth and beauty in creation is what the liberal arts are about, and I believe we do that with inorganic chemistry. I think the most interesting thing is this question, what do we do with it? Has anyone gotten that for, you're getting a liberal arts degree, or you're doing liberal arts education, what are you going to do with it? Does anyone have a really good answer they'd like to share, like something that they say when they get asked, what are you going to do with your classic studies? I don't know, my answer is anything you like. Really, if you get through the trivium and the quadrivium, you can go do chemistry even if you don't do anything else. Here, this is my planned drawing on the whiteboard. I actually love whiteboards. This is a chemistry problem, and I drew that in the wrong place, so I'll just go over here. Here's the ball, and then we've got here, oh, nope, brain is stupid, here it is. Okay, these are atoms, and this is a particular packing system. We have atomic centers. We can measure A, right? If we can measure A, and this is actually square root of 2A, we can determine experimentally the radius of the atom, right? This is a problem that throws off all sorts of undergraduate chemists in usually general chemistry 2, I think. It's literally just the Pythagorean theorem. It's literally just geometry. I think if I gave you a number for A, let's say it's 116 picometers, you don't have to care about the picometers. I think a lot of people could solve this, and a lot of students who have no classical background can't. They don't have any of the tools with which to approach the science, but if you go through the classical things, then you can do things with it. That's the whole point. You go do something that is your vocation or you're interested in, and if you're interested in chemistry, you are grounded for it. This is actually, I've been thinking about this since we talked about it, right? I also think that God made Adam and made him a gardener, and I believe that the sciences properly viewed is a form of gardening. It's a form of interacting with creation like a gardener. So that's my view of the sciences as part of the liberal arts. I think it's a little bit sad that we don't have an official table here, but since I'm a chemist, and I think that the church needs more chemists, I figured I'd tell this room full of people that Concordia, Wisconsin's chemistry program is a very good one. It's approval. I always forget whether it's certified, accredited, or approved, but it's essentially an accreditation process, but they call it approval. The ACS we've gone through that process, and we are good enough to be an ACS-approved program. So this is a place where you can study the sciences without constant assault on your faith. And then you can go into the sciences and maybe reclaim a little territory that we've lost. All right. As an intermission, I have a painting. I don't have any idea how it shows up for view because I've never presented with a screen this big. So this is Matisse, and it's a pointillist painting. And I think this goes with my concept with the puzzle pieces. First of all, I think it's beautiful. But second of all, you could potentially view this as a smattering of unrelated pieces of information. And it is something that you're required to do, is to put those information pieces together, right? And so that way of approaching the truth is actually a thing. It's a unitary thing. The truth, as fallen and limited, finite beings, we see snapshots, and it's our job to put those snapshots together. And we can do it right and we can do it wrong, and we're fallible, so we're likely to do it wrong. But it's our job to put those snapshots together. And that's actually, philosophically, why puzzles? So we'll get there. My presentation's a little bit like you're going to have to put the snapshots together, but we'll get there. To try to avoid it being like that, I've taken a couple major themes. So my first major theme is a brief comparison in the mindset of faith and science. So I'm not going to read what I wrote on the slides. I hate doing that. But when you're doing science, your job is to conform what you think to what you find in reality. I think a great example of that, I have a projection. This is an old plot. A projection of global warming temperatures. I believe this was made in 2005. You have all these models. It's a really beautiful, perfect theory. And then if you have observations, which is the black line, eventually when observations diverge from your predictions long enough, reality wins. And no matter how much you love your idea, you have to let go of it. That's how science should be done. I'm not saying that's how science is done. We approach this from the ideal way of doing science. I believe in the same way, when you want theological truth, no matter how you feel about a teaching, whether you understand the teaching, whether you like the teaching, if the Bible teaches it, you have to conform your thoughts to what the Bible teaches you, whether you like them or not. Or whether they make sense to you or not. Like, you can't really explain how Jesus was God and man. But that's not really your business. Your business is to believe what the Bible has taught you. I think this similar mindset is a place where we see that the sciences and theology are connected. And I already said that, so I'm just going to go on. The major theme, too, is postmodernism. And we're going to get there when it makes more sense. But science and the Christian faith have essentially the same understanding of truth. And so postmodernism is an assault on what are actually the sciences in the same way that it is an assault on the truth. All right. So now we're going to get into the way I run this lesson, some texts that I have students read. I teach this to college freshmen. I think any even partially classical high schoolers could do this work. I have to admit, I have no idea how you do things with high school because I never went to high school. I've never been to high school. I don't know what a high school class is like. It's a bit of an issue there, but that's the way it is. I have students read a section from A Canticle for Leibowitz by Walter Miller. Has anyone read A Canticle for Leibowitz? It's a good book? Okay, I'm glad that, yeah, I think it's a very, very good book. And then we have the transposition essay by C.S. Lewis. Transposition essay is one of the readings that all of the versions of the Science and Humanity class go through. And then I actually made them read some from something that I wrote. I have a small book of essays, and I make the students buy and read it. It's as cheap as I could possibly make it, so I don't feel bad about it. So I'm going to kind of give a brief overview of why we're reading each of those, and then I'm going to ask you to play the game with me and do the activity. All right, so A Canticle for Leibowitz. I'm going to have to give you a little bit of background about the story. The story takes place in the distant future after nuclear war has wiped out almost all of the Earth. They call it the flame deluge in the story. And the part that I have the students read is in the middle part where the monks have managed to save written documents and knowledge, and they frequently don't know exactly. They're essentially, they copy documents, they study documents, but they don't necessarily understand the documents, but they work on it. And they're being visited by a secular scholar. And the interaction in this fictional setting with a fictional set of discussions is really nice when you're talking to students, because we don't have to talk about things that people get emotional about because it's in a fictional setting. So what's happened is one of the monks has used the documents to make an arc lamp. An arc lamp is you take an electrode and another electrode and you just kick the crap out of electricity in it, and it's like a tiny little zap of electricity that gives off all sorts of light. And they hang this contraption up in the library, this is before, just to read by, and they have actually, the top, you put a light up at the top, it's also where there had been a crucifix. And so after a long discussion, and it's not really part here, the monk, one of the monks goes and takes down, the guy who made the arc lamp goes and takes it down, and the abbot has hung back up the crucifix. And what he says is like my theme for the class. He says something like, "Whoever studies here henceforth shall study ad lumina Christi." And my Latin is a long time ago. I talked to my classics friend who said ad is hard to translate. I don't know. There's all sorts of people who know exactly what that means, right? I was told it's sort of like toward the light of Christ. Does that sound reasonable? All right. He was a classics major at Hillsdale, so I figured he was trustworthy enough to help me with it. All right. So what we have there are two ways of viewing the world and truth. This is just a picture of an arc lamp from Wikipedia, and in my class we talk about this. This is like you can study by the light of science or the light of man, but you won't find the truth that way. That's one of the key ideas that we get to when we do this puzzle. To really get to the truth, you have to study everything. Toward the light of Christ or in this way. So, for example, and we take studying nature because I'm a scientist. I have a picture of a mountain I've climbed, work from a student, work of mine in chemistry. We're studying nature, and as we study nature, I'm about to disagree with all sorts of great minds from the past, and I feel a little hesitant. But I think if you study nature without the right starting point, you find that nature is, as Tennyson described him, nature is red in tooth and claw. Nature is vicious if you study nature honestly without the light of Christ. You will find, everything eats everything else. There's a video, I don't know if you've ever seen it, of a deer that eats a baby chicken. Right? It's shocking because we think of deer as being gentle, but for the large part in nature is fallen also. The deer are gentle because they don't have a choice, because they can't. They have to run away. So I think if you study wrongly, you will find that nature is brutal and unforgiving and cold. If you study properly through the light of Christ, you will find that the heavens declare the glory of God, and you will see the brutality of nature as being part of the fall and part of sin in the world. And then you can sort of see an image of what nature should have been, of what the garden was like, because it's still there. All right. So, again, I kind of just said that, so I'm going to move on. All right, so that's like the first idea. The transposition essay, again, I like kind of knowing, have any of you read it, heard of it, can raise your hand? I see a lot of hands from you, I appreciate it. You raised your hand for the Platonic solid, right? All right, so this is an essay where he talks about, it's a long essay and there's a lot of meat to it, but I don't want to overspend the time on it. So I'm going to take one example. And so one of his examples, he's talking about how you can have a higher medium and a lower medium. One of his examples is you can take an orchestral piece and you can transpose it down, that's why it's called transposition, to a lower medium, to the piano. And it can still be pretty on the piano, but it loses a significant amount of meaning being transposed from the higher medium to the lower medium. Really quick summary. There we go. All right, another example he gives is when you take 3 dimensions and you draw it in perspective. So that's the one that I can put on the screen. So that's the one I'm going to put up. Right? I can't put an orchestra there without all sorts of technology, and I don't like technology that well. So what we've got here are 2 drawings, and I confess I did not use a protractor, but I did draw this with the program, and these angles are very similar. We'll stop at very similar. We won't claim that they're exact. So we have angle ABC and angle EFG. And these 2 drawings with the same angle in 2 dimensions, both of these 2 dimensions, right, represent actual entirely opposite things from the real world, right? We know the 3-dimensional world because we live in it. But if you represent a road on the left, you end up drawing it in perspective, you draw a triangle. And if we represent a cube on the right, once you draw the cube, the perpendicular lines are now the same triangle. So not only do we sometimes just lose meaning, occasionally when you transpose from a higher medium to a lower medium, opposites suddenly look the same. So this is an illustration he also gives of human emotions, how when you're excited or afraid, those are completely different things, but your body reacts the same way. If you study the natural world, assuming there's nothing but the natural world, you can do that and be logically consistent. Not correct, but logically consistent. You may find occasional clues that there's something else, but you can trap yourself essentially in the 2D world. And he imagines this as a 2D world, as a 2D being who refuses to believe that the parallel lines are not a triangle. So the idea of this transposition is that in order to actually know about the higher medium, you have to be told about it. And that's the incarnation. God enters our medium to tell us about something that we can't learn just by looking. All right, and so we say that sort of thing. All right. Last text. It's like 12 essays. It's not very long. I've been working on science and the church, and I like very much the church militant hymns and the church militant idea. I really appreciated in the plenary this morning talking about how we're on a battlefield and we have to train the artillery fire into where the enemy actually is. I was like cheering, but cheering like an introvert, so I was sitting in the back smiling. So, what goes with this is we talk about in these that science and the faith both depend on the idea that something that's true is true for no matter where you're born, no matter what your culture is. If it's true, it's true. It doesn't become untrue because it's a different person thinking about it. It's part of my campaign against postmodernism. So, again, perhaps because I'm nerdier than the room put together, I know about Oda Nobunaga, who was a Japanese warlord in the 1500s. He, again, I think this is from Wikipedia, so I think that's fine, right? He took the blue area and then conquered half of Japan. So he's like a big figure in Japanese history. And the point in this essay is Oda Nobunaga and the acceleration due to gravity. So the acceleration due to gravity is 32 feet per second squared. Whether you're me today in this building or Oda Nobunaga in 1500s Japan, it doesn't matter who's measuring it. And if you can't have that confidence in the truth, you actually can't do science. And it's the same confidence in the truth, it's the same idea of the truth that we use in the church, right? The truth of Scripture is the same whether you're me or whether you're in Africa or whether you're from India or Japan, right? So I have and I don't think it's wise to actually play. There's a really fun video of this guy convinced, I mean, he's BBC, so I didn't have that much trouble. They drop a bowling ball and feathers from the top of a giant vacuum chamber that's used for testing rocket parts. And if there's air in the room, the bowling ball goes boom, and the feathers float down, right? That's what everyone expects. But if you pump the air out, you have the acceleration due to gravity, and both of them, boom. Right? The only reason the feathers float down is they're being held up by the air. And I used this example in class because it doesn't matter who does this experiment. Oda Nobunaga could be teleported, that's not the right word, teletimed. Anyway, we could time travel and get Oda Nobunaga up here, and he could do the experiment, and the feathers will still fall with the bowling ball at perfectly the same location as long as you pump out all the air. All right. So this is going to bring me back briefly to postmodernism, and this is an idea that some ideas you're really sure about, and some ideas you think are really good, but you haven't really. So I'd be delighted to talk afterwards if somebody likes this idea or thinks there's a problem with it, but I believe that postmodernism, scientism, and appeals to consensus are all related, and I've put together my reasoning for that and share it with you now. So postmodernism essentially is everyone in this room actually literally affects reality for themselves by what they think. The odd problem with that is if everyone came up here, they'd find that the table is hard, right? And the wall is hard, and this chair is kind of squishy and blue, right? So you have to deal with the fact that there are at least some things that it appears people generally have the same view of. Now, moral things, everybody, as it says, does what was right in their own eyes. So there must be something about the physical world, next step. See, we've got the square to the pentagon to the hexagon to the heptagon. So the next step is there must be something in this physical world that somehow makes it at least more likely to be the same for everybody. Therefore, science, this is scientism, science is the only source of communicatable, even the possibility of an authority, because it's the only thing we have any experience of being the same for people. Like, what color is the piano? It's black, right? We can all do that with physical things. So if you have scientism, that's my step there. We move on to the green heptagon. We can't give up. The reality is dependent on observers. So if we want to be really sure-ish as we can be, we will look to a consensus of experts. So I believe anytime you hear, consensus of scientists, I mean, science doesn't work that way, but any appeal to 97% of scientists believe this is essentially the same philosophically. It's at least in the same boat with postmodernism. Anyway, that's a new thought, and we'll see how you guys handle it. All right, so I would like to move on, and I'd like you to play, and if you really don't want to, you can sit, but I have 8 puzzles around this edge of the room. If you could form groups and talk to each other. First, you don't really have to talk about ideas. I'd like you have one goal and 2 rules to do this properly. The one goal is to put your puzzle together. And the 2 rules are don't look anything up and don't flip the puzzle pieces over. All right, so if you could go ahead and go, I was going to go place to place and talk to people some, and we'll see how this goes. If you can't get a puzzle, at least go look and see.
Hey, do you have numbers? Take it over.
Corner.
All right, who finished their puzzles? Can your groups raise your hand? Okay, I guess we'll just go around. I'm going to start over here. Tell the room, what did you guys have? Greek letters, and did you use the Greek letters or did you just use the shapes? Okay, and the next group, what did you have?
We had molecules and ions.
Ah, excellent, you did. You had the spectrochemical series, so it's an inorganic chemistry thing. That's something that's very narrowly to my field, and could be anything that's very narrowly to someone's field. Kind of the point is the clues are not all the same difficulty. When you're trying to put together truth and you're trying to put the pieces of the painting in order, you don't get to pick how hard it is for you. Did you guys finish? What did you guys also had periodic table, right? Did you notice that did you figure out where the blank puzzle piece went? That's sort of also an inorganic chemist joke. That's for technetium, so that's actually the transition metals, but the naturally occurring ones. Anyway, I think the group that's still working must also have the spectrochemical series. I would like, this is planned for like 15 students in a room. So if you could, try to figure out where, does anyone have a full puzzle? You've all got part of the puzzle. You don't. You don't. I'm sorry. Nobody has a full puzzle. I don't know when I'm done. Does anyone know when I'm done? I have a little while still, so I can have everybody. I'd like you to go look and see if you can figure out where your puzzle is, the other part or parts of your puzzle. So just look at yours and go see what else you've got. What we're looking at, what I think everyone just did, is analogous to science. You use the clues that are available to you to try to assemble something, right?
Which one are you? Where's yours?
Maybe that one matches.
You have Greek letters?
Oh, do they have to be the same? Yeah, it has to be the same.
And science does a really good job with that. How do we get to see the other side?
Put it back together.
So we have to observe through geology. When I needed another puzzle. So I don't think this is going to break anything, but maybe you move back. Pieces kind of go together than the big ones. The big ones, there's two different puzzles involved. And first, we were going to put the chemistry ones together from the written clues, but it turned out that that was wrong. So one of the things we can talk about with this is that there are actually a lot of plausible ways to put the pieces of truth together. But that doesn't mean that they're all right. That means that you can't tell the difference without the light of Christ. There is a right way to put the puzzle together, but you have to have a different vision of it. Otherwise, you can just kind of, these look like they should go together, and you jam them together. So what I'm going to try to do is turn over a puzzle. But before that, I want to put something up on the front screen. On the other side of these puzzles, you need like big piece puzzles that don't have lots of pieces. It's dumb stuff. So what I really, next time I do this, I want something beautiful on the other side. So next time I do this, I'm going to special order, 50-piece puzzles with this. This is actually a painting from my father. And so I want pretty stuff on the other side, and we're not going to get that today. So imagine that that's what's on the other side. And I found that there's a lot of opportunities. I do this with students in groups of 3 or 4 so that I can actually discuss with students. I think education really depends on individual interactions between the teacher and the students. So I try to make as much of that as possible. So I've talked about almost anything with this. I do have some printouts. I wasn't going to pass out all the handouts, but if you want to see what I gave to students and you'd like a copy, I can give you a copy later. I have them think through after they do it. So for the students, I just have them, they've already talked about these other things before. They've done discussions on it, and I've made them practice talking to each other. So they're getting better at that. But I have them think through questions like, my first question, did you aimlessly stir the puzzle pieces? I think a lot of untrained thought is the equivalent of taking the puzzle pieces into a bowl and just kind of stirring them and hoping that you get somewhere. So I want them to think about how they thought about it. I want them to think about what kinds of clues they used and the different types of clues. Like sometimes the clues where I told them, that's the spectrochemical series, there's no way you're going to get that, right? So go ahead and now look it up. Like we didn't do that because this is sort of a demonstration, but and then I'll have the students look it up, and then they can use that information to put the puzzle together. As I told one group, this happens to me in class because I have different conversations with every group. The students have the easiest time. I have a Fibonacci sequence. Did anyone notice it was a Fibonacci sequence? Okay, great. So I had a Fibonacci sequence, but they don't necessarily notice that. Some of them do, some of them don't. But it's numerical order once you get past the point that there's two ones. Then you just line them up in increasing number and you get it. So that one goes easy. And oddly enough, the spectrochemical series, the one that's really my area specific, goes easy because they ignore the clues they don't understand and they use the clues that they have and they put the puzzle together. They get tripped up on the ones that they almost know, and they don't stop using the clue that's giving them trouble and start using the clue that's easier. So they'll be like, I don't know which order the Greek alphabet letters come in, and maybe it's this one, maybe it's that one. And those are the people who take longest every time. So I have them think about that. I have them think about the fact that there's both objective and subjective difficulty in understanding the truth. Objectively, it's harder to work out the spectrochemical series than it is to work out even, I had like a series, some of them were math problems, some of them were numbers, but if you did the little math problem, it was numerical order. It was like 1, 2, pi, something like that. So the clues are objectively harder or easier, but they're also subjectively harder or easier. So some of you really know the Greek alphabet. So if you walk up to it, that's really easy for you because you've learned that, right? So when you're putting together pieces of truth, you shouldn't be surprised when sometimes it's hard for you and sometimes it's not. And sometimes it's hard for you objectively and sometimes it's subjectively hard for you. I talked to them about, how long did it take you to notice you had part of a puzzle? Is the question we talk about. And we talk about how you put the puzzle pieces together and how you know which ones go together. And then, like I said at the back, I like trying to bring it together where the back of the puzzle that's plain and less rich, right, is our representation of the lower medium and the scientific world. And the other side, which we're going to all pretend was that, is much more meaningful, much richer, but you can only actually see it if you put the puzzle pieces together correctly through the Word of God and you understand through the light of Christ the higher medium, which is the 3D world. I think I'm set, and I'd like to talk about any questions you have. I'd be delighted to discuss ideas with anybody who wanted to. And if you don't want to do that and you decide to go, I'm fine with that. I have handouts of things if you were interested. I have what I gave students the last time. I made a number of copies of, I tried to brainstorm sort of after the fact, major discussions I had with students and what kinds of things I talked about. And I put in all the class discussion questions that I actually did with students on the readings that I told you about. So if you're interested in any of those, you can come talk to me. I'll give you the handout. And otherwise, I really appreciate your time and attention. Thank you. There's my coffee.
Can you buy your book of essays on the...
Yeah, it's at Barnes & Noble. I mean, it's at Amazon too, but I hate Amazon, so.
I
Yeah.
don't know how much you can comment on this and how much you want to, but I guess I'm a your academic environment, what the pressures are, one way or another, to teach science really from a biblical worldview, or to separate science and faith? Because I think there are two camps in that. I think I've noticed a little bit there's some pressure to keep them separate, to really, I don't know, do you?
Yeah, I think my view is most of the scientists I work with don't really want to touch it because it's a discussion that has so many moving parts. We all want to integrate faith with the science. I have a lot of respect for my science colleagues. I think that that's one of their goals, but a lot of them are uncomfortable with the process of it, and I try to do what I can with that, because I think that the two work together. I think science is an appropriate vocation for a Christian, and God uses scientists to do His work. They're usually different from normal people. We're pedantic and can be irritating about odd things, and there's a role for that as long as you point it in the right direction. I don't know if I just wandered on your question or not.
And I guess where it's sort of coming from is that, looking ahead at, admissions for our teenage kids and so on, it's a question I'm asking of Christian universities, of Concordia universities, actually, the admissions, how are you dealing in your science courses? Are you teaching from a biblical worldview? And, one of the most disturbing answers I got, and it was, we teach science and we teach theology courses, and we let the students decide between the two worldviews. Yeah, and I thought was really disturbing.
I would agree that that's an incorrect answer. I have trouble with tact, so I'm working at it. So I try very much. Every science class I teach, I introduce. Chemistry classes, like if you think of that list, we don't have time for a unit on how science and faith go together. We have to handle this in other ways. But in every chemistry class I teach, I do faith and science discussions or assignments. My favorite thing that I do is I take the senior seminar students for chemistry, and I have a faith and science group discussion where they read what I tell them to read, and then we talk about it, and then we have individual discussions the next semester. I think there's a place for more science and the Christian faith. Like the science and humanity class, I think, is a really good class at Concordia. I also want like a 300 level class that's science and the Christian faith. Maybe I'll teach it one day. But I think it's important to have them together.
Yeah, I think it's becoming just I'm realizing that that's actually probably one of the key questions to ask that for me kind of illuminates where we're at with the Christian university, like what they say about theology is one thing, but what they say about science actually tells a lot more.
It can tell a lot, especially since, we can't treat science as if you study science, you've gone off to study the dark arts of the enemy. Because then that's essentially admitting the proposition that the sciences are implacably opposed to the faith. And so that's not at all correct. I petered out there.
Yeah. You noted that when it comes to our way of thinking, we have to conform our thoughts and opinions to reality on the one hand, and the Word of God on the other. Whether we like it or not, this is reality, this is what God's Word says, and you can't change either of those. What about when they seem to come into conflict? What do you teach your students?
So that's a whole massive, long discussion, but the brief summary is the Word of God is authoritative and anything God deemed fit to put in it. So if what you see in the physical world seems to conflict, there's a perception problem. You don't necessarily understand properly. So there's a level of humility you have to have there. And science is remarkably changeable. So, you shouldn't not know the current scientific theory, but you should just sort of set it there. I don't know if that answers. Well, I think if you have more questions, please come up and talk to me, and thank you again so much, and have a good afternoon.
paper and slide underneath of it.
And then,
Yeah.
are we supposed to find and connect or just find?
No, just find where.
All right, let's go. Is that this way? I think it is over there.
Okay. I just want to see them all anyway.
Yeah.
Let's even get this one.
It doesn't happen in the paper side. Ours are loose.
Periodic table. That's what that's what
Oh, this one. Yeah. No? Well, I don't think potentially. Look how big the spaces are.
I guess it's not.
Does it mean like literally? Oh, I don't know. Like it must.